Hi and welcome everyone to this SIG Cluster Lifecycle introduction session. Today we're going to talk about what our special interest group is doing, where we meet, how often, and what our plans are for the future, and also what we have done so far. So I'm Käldström, SIG Cluster Lifecycle co-lead and CNCF ambassador. I'm doing contracting for Weaveworks while I'm not in high school. So,
and yeah. I'm Justin Santa Barbara. I co-lead the AWS SIG, originally created kops and maintained that with a big community, and recently joined Google.
Cool. So SIG Cluster Lifecycle basically examines how you can change Kubernetes to make it easier to operate. Easier to create clusters, to configure them, and to upgrade them, for example. High availability is also a question like how do we make that whole process easier to manage, certificate rotation, everything, etcd management. We're going to talk about this more later. So we've divided our responsibilities and work items into 5 logical pieces of work. And the first one is control plane installation management. So this is basically, kubeadm is the output of this effort. I want to get Kubernetes up and running as quickly as possible, as smoothly as possible, and as fast as possible. So, for example, we've deprecated the old guides, getting started guides that have been outdated for a long time, and instead replacing them with kubeadm that we consider being a building block for the future. And generally improving docs as part of this, but also control plane configuration management. So how do I specify arguments to the API server, for example? How do I configure my kubeproxy add-on? Or how do I run kubedns? Stuff like that. Our SIG has published guidelines for component configuration, which is this structured API, like all other Kubernetes APIs, that you can pass to Kubernetes components. So if I want to run the kubelet, for example, with a specific set of configuration, I can use command line flags, but I also can pass it a YAML file that is structured in the same way as any other Kubernetes object. And now we're also building a cluster API, which we'll talk more about later.
Yes, and so those first 2 items, we sort of have a control plane up, we have it configured. There's another piece of the cluster API, which is the machines API, and this is about bringing new nodes or machines into your cluster, scaling it up and down, destroying them, doing rolling updates. So that's the third area. And then the next area is add-on management. So you have a basic cluster up and running, but typically you need definitely some core system add-ons. You'll almost definitely need almost definitely need a CNI network provider, for example. You'll need a DNS. It's very debatable what is the control plane and what is, you're moving out into user space, but there's definitely some core of system add-ons which we probably need to install as part of our group and think about the configuration of and the life cycle of. Some of those things will change, the versions of those things will change and need to be upgraded alongside your Kubernetes upgrades, like DNS. So that one's a pretty active area of debate right now. We can't even really necessarily decide exactly what is in and out of scope there, but we know that there is definitely bits that are in scope there and that need to be addressed.
Yeah.
And then the final one, which is sort of I think the most contentious, but actually I think everyone wants someone to deal with it, and so SIG Cluster Lifecycle seems to be the one that is willing to do that. I'm a big proponent of it personally. Everyone finds etcd very challenging to operate and manage. That's not entirely etcd's fault. It's really because we've put all of our control plane state into etcd, and so it is therefore the one piece. We put all the hard stuff into etcd, and so surprisingly enough, etcd is hard. So that's the 5th pillar, I guess, of our work.
Yeah.
Yeah. And so the little bit about what the Cluster API is. This is very much in alpha. I'm not even sure it's technically. I don't know when we're planning on pulling it past alpha. I'm sure someone can tell me.
Later this year. Yeah.
Not yet.
In the future.
But this is sort of the vision. The API is actually doing pretty well at the moment. So we have a good idea of what the API will look like. The implementations are much more of a work in progress, but there's actually some really exciting implementations happening right now. And so come along to the office hours. I don't know. We have meetings on Wednesdays, which are really exciting to see what happens there. Great progress in that area. But the Cluster API defines a bunch of new API types in the Kubernetes API. The first one it defines is a cluster, which is a container for the sort of cluster level configuration, your generic, or not generic, your broad cluster configuration. Things like your networking configuration is the primary one right now. Then we have another object called a machine, and a machine is this is a circular definition, but a single physical or virtual machine. So it might be an instance on Google Cloud or Amazon. It might be a physical piece of hardware. It's different from a node in that the machine hasn't yet, a machine becomes a node, but a machine has not yet registered as a node. It is a request typically to provision a machine. There we are. So, and we'll talk about the controller. There's a controller that will basically create that, create a machine or provision a machine or get control of a machine from a pool, for example, in a physical environment. And what's good about this is it lets us build up these other concepts called machine sets and machine deployments. So if we think of a machine as being like a pod, we have on top of that, in Kubernetes, we have on top of pods, we have replica sets and deployments. And most people now work with deployments instead of at the pod level. And it's the same thing here. The intention is most people will work with machine deployments, and then a machine deployment controller will create machine sets. A machine set controller will create machines, and then the machine controller will go and create or requisition the actual machines. Flip to the next one.
Yeah, so it's when we have this set of API specs, the aim in the future is that we can have this specification in a YAML file, for example, and if we give it to the VMware tool, it will spin up this specification in a VMware cluster. If we give it to the AWS tool that implements this, it will do its thing in AWS. If we give it to kops, it can do both AWS or GC or whatever. And then we will have a much higher, we can unify, yeah, the next one. That says we can unify more the now kind of fragmented base of tools we have.
Yeah, exactly. And I think what's particularly exciting is that like if you imagine what GCE or AWS or Azure have to do, they really only have to implement one controller, the machine controller, and we can share those higher level controllers, the machine set, the machine deployment controllers. And so, we have this incredible diversity of tooling right now, and hopefully we can try to unify at least the user experience of it, so you'll be working with machine deployments and not have to worry as much about, kops or kubeadm or whatever tooling you decide to use.
So here is a diagram of what this all looks like, and first we start with some kind of infrastructure, be it my Raspberry Pi stack at home, or my physical boxes at the office, or like AWS, Azure, GCP, whatever, but somewhere where we have access to a couple of machines. On top of these machines, so the layer 1 is then infrastructure machines. Layer 2 is we use kubeadm, for example, as a building block to bootstrap the cluster and create a unified Kubernetes cluster. So on top of this layer 2, we can completely rely on the Kubernetes API. And kubeadm executes locally on each one of these. For example, kubeadm init gives you a master, and kubeadm join gives you a node. And now that we have the Kubernetes API, we can start adding add-ons on top of it, running DNS, proxy, cloud provider specific stuff, load balancer, monitoring, logging, you name it. And then we also have the kind of cluster API controllers that now we can start running a normal controller, a reconciliation loop that checks, am I running the amount of nodes I should in my machine deployment, or should I create more? Am I running too many? Are some of the machines unhealthy? And this small controller, as Justin said, that handles the machines is environment specific, but the rest of the API and the rest of the higher level controllers are the same. And therefore we can share as much as possible by using kubeadm as the building block for bootstrapping, by using cluster API controllers for higher level operations, and Kubernetes in between to run all applications and add-ons. And also people tend to ask, what is the difference between kubeadm and kops? And here I try to summarize it. So kubeadm is the small thing that runs, just gets the cluster up and running to the bare minimum level that you could even call a Kubernetes cluster. No extra add-ons, not even a network provider. You have to give that yourself. But kops has a much larger scope and basically wraps everything, the whole world. It installs cloud provider add-ons, load balancers, monitoring, things like that, and it's also one of the new consumers of Cluster API spec. So you give the specification of what you want in the Cluster API to kops, and it will do its thing in the future. As said, the Cluster API is still in alpha. We have a working group for it inside of the Cluster Lifecycle that meet on Wednesdays. So please do come and get in touch and get involved with that effort if you have ideas. And for kubeadm, it should set up a best practice cluster, but not anything more. Just the bare minimum, and be as secure as possible for each minor version, and so on and so forth. The user experience should be simple. We aim for this like kubeadm init, and you're basically done. You just have to install like Weave or Flannel or Calico or whatever of your choice. And then we have the scope is limited, unlike kops, and it's intended to be a building block. So if you don't want to do everything that kubeadm init does for you, basically spinning up the whole master, you can, for example, just generate certificates with the kubeadm face command. So kubeadm face certificates generate the required certificates for kind of any Kubernetes cluster. Or if you want to create the control plane configuration, or if you just want to install kubeDNS or core DNS, there's a face for that as well. That can be atomically executed. And kubeadm only ever deals with the local file system, putting files on disk, switching around, and the Kubernetes API. Either it's a client to the API, or it creates files on disk required for Kubernetes to run. And kubeadm actually doesn't care about how the kubelet is run. It just assumes a kubelet is running somewhere. And that means you can run it Dockerized, you can run it on systemd, you can run it however you want, but as long as you have something that executes. And favoring one specific CNI implementation is out of scope. That was one of the early design decisions. You should be able to choose your favorites, and then it's just a kubectl apply away after kubeadm init. Yeah, I touched on the faces thing. And the audience for kubeadm is people who build their first cluster, people who have these three machines at their office. They want to stitch them together and have a Kubernetes, or that is one group, or higher level tools like kops, Kubicorn, Cluster API implementations, or larger enterprise services like GKE and people like that. The plan is for kops to use kubeadm in the future as part of the conversion to Cluster API. So recently, Kubernetes 1.10 was released, and with that, kubeadm as well, as part of the release process. That gave us support for advanced auditing, TLS encryption for the local etcd on the master, and an update to etcd 3.2 as part of the rest of Kubernetes as well. And core DNS graduated to beta, so now it's available. You can run kubeadm in it and feature gates core DNS true, and it should work.
Yeah, and we recently released kops 1.9. Kops has a delayed release schedule. We're shifting to a faster release schedule, but the decision we had previously made was that the release of kops 1.9 means that Kubernetes 1.9 and kops 1.9 and all the CNI providers and everything we install is believed production ready. So that's why kops tends to lag by typically about a whole minor release. So we recently released 1.9, 1.9 support, obviously bug fixes. There's a huge change list if you want to check it out, but the big ones are sort of improved GCE support. There's initial DigitalOcean support going in there, which I'm excited about. And we have a sort of plan for etcd, and so the real thing that's happening right now is trying to make sure that we have a plan to get everyone able to move to an etcd manager that will let people migrate from etcd 2 to etcd 3 or 3.2 to 3.3 or single nodes to multi-nodes and all the various etcd permutations that are possible. And the alpha, the cluster API is going great. I think that's I don't know whether it's a sub-project of the...
Yeah, technically it's a sub-project of the special interest group Cluster Lifecycle.
Yeah. So the spec is there. It's at Kubernetes SIG's, github.com/Kubernetes SIG's cluster-API. The spec is in great shape, I think. The API is in great shape, and there's some implementations happening. There's a sort of canonical GCE implementation, and there are lots of other ones in the community which are great and exciting to see.
Yeah, chances are high that if you talk to someone of the providers here about the Cluster API, they have plans to start using it or have already a prototype in place.
So yeah, a quick overview of what kops does. So a easy for the user, but very, very opinionated way of building clusters on AWS and GCE and other ones in future. So the sort of user experience, kops create cluster, the DNS name of my cluster. Here we're doing one with 3 masters, and we want to run all 3 masters in one zone. In AWS, it looks like not necessarily the best idea to put all in one zone, but I ran out of space on the slide, so all in one zone. And then that creates some API objects. Actually, kops sort of creates them in S3, but we'll see what happens with the cluster API. And then this update cluster command will actually go and create the API objects, create the AWS objects in this case, and spin up a whole cluster for you. And so you're able to kubectl, get nodes, or whatever. Use kubectl from that point on. So that's the full installation, cluster creation experience. And AWS and GCE support is great at this point. Technically, I think GCE is in alpha, but as a recent Googler, I think I better fix that pretty soon. And we have community support coming for DigitalOcean, Alibaba, OpenStack, a couple more. So lots of community activity there, and github.com/Kubernetes/kops if you want to come check it out. The big items on the roadmap. So currently, kops combines everything into one sort of mega opinionated system, and sort of working on splitting that out into components and becoming more modular. You'll see this sort of lines up a lot with the cluster lifecycle goals. So the hope is to sort of provide those as opinions and options that we can consider for the cluster API. So for the cluster lifecycle work items. So obviously we want to adopt the cluster machines API. The machines API itself will be much easier for kops to adopt than the cluster API. So the machines API is really where we're focusing initially. Kops has an add-on manager, for better or worse, that's built into it right now. It would be great to share some of our positive and negative learnings about that, and sort of make some progress on add-on management. One of the big goals, I think, of add-on management is to take that. If we get a good add-on manager, we don't have to worry as much about add-ons in Cluster Lifecycle. In other words, the idea is to build the framework so that we don't have to update kops every time a new Calico version comes out, which is the current situation, and is sort of not a great situation to be in. So we want to sort of make that a generic add-on manager across all the tooling. etcd manager, we need something to operate etcd. Kops has one built in, and we're working on splitting that out to be more generic and reusable and powerful. To allow upgrades as well. That's a lot of the kops users are using etcd. Most kops users are using etcd2 because of sort of the timelines of when people started using kops and when kops started, and we are sort of leading working on the work to get from etcd2 to etcd3. Not sure why I wrote kops. Something kops.
So where are we going from here? Well, we want to get things into a GA state, of course, and get them more production ready. And for example, kubeadm is right now in the beta state, and it has been that for a year. In order to graduate it to general availability, we need basically the component configuration that I talked about earlier. There's like one component configuration for each component in Kubernetes, but most of these are in the alpha state right now because the community in general hasn't really yet decided on the exact format or structure of these configuration types. And in order for us to promote kubeadm to GA, we have to have these component configuration types at least in the beta state, so people can rely on them for kubeadm's configuration in turn. So that is one thing we're working on with the rest of Kubernetes community. And then the cluster API spec itself would be nice to have in beta shape probably later this year. And yeah, component configuration, as I talked about, together with the rest of the community. And then SIG Cluster Lifecycle also deals with documentation as everyone else. And for example, things we want to improve still is our recommended cluster parameters. So what is the recommended configuration for a 3-master 10-node cluster, for example? Are there any gotchas when you're scaling up to 50 nodes or to 500 or 1,000? So working with others in the community there, for example, SIG scalability is a key factor. And then highly available cluster deployments. Earlier, or December or something last year, we created a guide on Kubernetes IO docs to how you can create a AJ cluster with kubeadm. And that is, I mean, there's always room for improvement there to streamline that flow even more. And more in general, talk about how we could make Kubernetes AJ a bit simpler. And then external dependencies are all, like, there's a lot of external dependencies for Kubernetes, like the runtime, sometimes even for kops deals with the OS, for example, when you package everything in one place. So what is recommended, like what are the needed kernel modules and whatnot. So recommendations on such things, etcd versions, things like that. And then there is a getting started from scratch guide on the Kubernetes IO docs. Unfortunately, that's not owned by a SIG right now. It's just organically been updated once in a while by drive-by people. But we're looking into getting SIG Cluster Lifecycle to actually own that and rewrite it so it actually is updated to this year's tooling. And And so how can you contribute to the SIG? We have a document where we still need to fill in some kops stuff and cluster API. But we'll share these slides afterwards so you can find the link. And also, you can find it from the other SIG Cluster Lifecycle documents from Kubernetes/community. We're working growing the number of contributors, reviewers, and approvers to scale the SIG. We have office hours for kops bi-weekly. It's on Fridays.
Every other Friday. I don't know which Friday is one, though, but yes.
Yeah. And for kubeadm is every Wednesday, as far as I know. And the SIG meeting itself is on Tuesday. You'll find the exact time in your time zone on the Kubernetes community repo. And then we have Kubernetes kubeadm for tracking kubeadm issues. Eventually, we'll move out the code there after our release process is more flexible to multiple repos. And then we have, so that we have like milestones for each release. So if you want to chime in and help, come to our SIG meetings and first ask the persons, but you can also go direct and see what are the things we're thinking about looking at for example, 1.11. And yeah,
There's some links there to the kops repo, and we have a roadmap, and yeah, please come along and if you're interested.
We have 8 minutes left, and for questions, related talks are, I have a talk on what is a production-ready, what could be considered a production-ready cluster. Some thoughts about that and what it actually means, because it's like production-ready is a buzzword, like people throw around it a lot, but what is the meaning, and do we actually agree with each other what a production-ready cluster means? Could we find some kind of definition even? Then we have also a kubeadm deep dive, which is also on Friday, and a kops intro. Did you have anything else for kops than the intro?
No, there's a hack session tomorrow night. Tonight up on kops or AWS or I don't know if kubeadm or whatever you want. But so if you're interested, then do come along on that. But it starts at I think 8:20, so we'll see how many people actually show up.
And yeah, here are a lot of links. You can join us on Slack. That's where the much of the communication is happening. We concluded we have already 5 different channels, so you should be able to find us somewhere at least. We've written some blog posts on the Kubernetes blog, latest in January and August last year. There's documentation, and yeah, our meeting notes is a good source of information what we're thinking about doing at this time. Yeah, do we have questions? We have 7 minutes for questions.
Thanks. So I think Google maintains these useful yum and apt repos for kubelet, kube control, et cetera, and I've only seen them referenced in the kubeadm guides, and I was wondering if those repos are associated with the SIG, or sort of who owns them. What maybe that's kind of an off-topic question, but
sorry, who owns which repo?
Those apt and yum repos. Does the SIG own them, or is that just kind of a Google repo?
So, I mean, ownership is hard, but I would say SIG Cluster Lifecycle owns them together with SIG release. The tricky part is only Googlers can push to these repos and actually make changes. So we're dependent on a Googler doing releases, and for example, after each release, a Googler has to go in, or actually that has changed now. Yeah, now it's part of the release. Formally, it used to be like we release 1.8, and then a Googler has to go and upload the debs and RPMs that sometimes took like 20 hours, and then people were confused, like, we have a new Kubernetes version, but not new debs and RPMs, and I want to try it now. So we got a bug issues filed for that, but now it's streamlined, so yeah.
I think the background is like we need somewhere to store the signing keys. Currently, Google has infrastructure to do that, so they stepped up. I think there's a move to move that to the CNCF, and that will help with the multi-repo type scenario. I think SIG release is the one that's really sort of driving that process, and we would be more consumers of that effort. But yeah, it's who holds the secrets is sort of the problem.
Yeah, there's a general move towards CNCF infra, but most of the things are disruptive, so we're trying to go step by step, and those changes are often managed by SIG release.
So I saw that Kubecorn wants to use Cluster API. Kops is now doing the same. How do these two relate to each other?
So I mean, Kops and Kubecorn, I think, I don't know if Chris is here. I don't see her. But they're different toolings with different opinions, I think. I think the hope is that all the installation tools, like it's not just Kops and Kubecorn, there's a whole bunch of them, and I think the hope is that we'll all use that API. I mean, I can speak to Kops has our own API types currently, so it's definitely going to be non-trivial to figure out how to do that without breaking existing users. I don't know. I would hope that, my hope is that if, I remember now why I had Kops as the last little thing there. It's because the idea is that the things that will be left in Kops will be so small that the tooling will be, pretty trivial. So the hope, at least for Kops, is that Kops essentially becomes a very thin shim over commodity Kubernetes components. So the hope is that, these differences will be, do you prefer to type Kops or Kubecorn or whatever your tooling is?
Hey, my name's Lee. I help Chris and Marco with the Kubecorn project. Just to Justin's point about how, obviously Kops is a very important piece of tooling and infrastructure in the Kubernetes community. Kubecorn is not. So if you want to help us build the right thing, send us a PR. We probably won't even review it. We'll just merge it, so,
Awesome, yeah, get contributing, and then we'll come to you.
So I have the question about the cluster API and the types in there. So you have this machine deployment and control for that, which creates machine scale set, then machine scale set controller creates machines. And then the implementation has to deal with the machines, and this is provider specific, let's say. So is it possible for the implementation to use, for example, Azure scale sets or AWS auto-scaling groups? How does that fit with the design, and is there a plan for that?
Yeah, I mean, I think that as far as I know, nobody has built one that, yes, but I think the design can incorporate it, but here is an update on implementation.
Okay, so originally there was some of this discussion flowing about, especially for the machine sets. However, right now Google, internally, they don't use mirrors for the mix, the auto-scaling group. So I mean, it's very hard to provide this behavior that is a requirement for this automation. So, and the problem is that you have to re-implement the machine set for different cloud providers. And with having only the machine creation and deletion and operation implementation, it's much easier.
Do we have any last minute questions? We have 1-2 minutes.
Do you have some plans for the roadmap of KOps, for example, externalizing HCD, moving it out from the master nodes? Because there are some issues some issues open for 2 years, yeah, still bothers me, this etcd thing.
Yeah, I mean, so the current answer is no. There is sort of a meta problem, which is that the only configuration that's tested right now is with etcd on the master. I think one of the goals of the etcd process would be to try to make it so that we lose that tight binding, where the API server currently talks to etcd on localhost and doesn't have to sort of discover etcd, and that will then make it easier to get that into end-to-end testing, and then we'll be able to figure out, what happens to performance, because it is. You're right. It is an issue that they are co-located and you have to scale them together. I guess the question is it going to be better to scale it up or just separate them out? And I think CoreOS was a big proponent of running them separately, if I recall correctly. I don't know. Do you want to give some background on your question? But I think that'd be a great way to get involved if you're interested in getting involved. But yeah, getting it under testing would be a great first step.
Yeah, and there was some other question there, I think.
Hi, the cloud provider control loops are moving out of the controller manager in core Kubernetes. Do you have any plans to enforce that in the cluster lifecycle components?
Can you repeat the question, Justin?
Yes, so I think this is about moving the cloud provider controllers out of Kube Controller Manager into, I guess, a per cloud provider cloud controller manager. And the question was, are there plans to enforce that in SIG Cluster Lifecycle, essentially to require it?
Yeah, so cloud provider refactoring workgroup was formed for exactly this purpose last fall. And they've been doing great work so far. And work is ongoing to split it up to different repos. The exact name or place of the repo isn't, as far as I know, decided fully upon yet. But there is the current situation is deprecated, and we're looking to run the cloud-specific controllers in this cloud controller manager only. And are working with the rest of the community to work out edge cases like improving the node registration process in a way that is flexible enough for a controller to deal with them, and things like that. But yeah, plans are to enforce the move out, but we don't know exactly when that's going to happen, because we have to support the current users for a pretty long period. I think it's 1 year. For stable features in Kubernetes, the replication period is 1 year. So first, now that CSI is in, it's much easier to, in beta, it's much easier to move out the cloud provider specific volume parts, which has been the issue so far. So later this year, and then we have to wait approximately 1 year, at least, for the replication.
Any other questions? Last questions? Otherwise?
Yeah, we're 3 minutes over, I think. So.
Or you can come talk to us at the front. Thank you so much for coming.
Thank you.